So I'm Carter.
I'm Sydney.
I'm Lil.
So today in this video, we're going to be demonstrating the permutation tests within R. And today we're going to do that with a research question, which is, do red and white wine have different mean acidity levels?
So the first thing that we did was we had two different data sets, one for white wine and one for red wine. And to make it a bit easier to use the data, we merged the two data sets. So the first thing we did was import each one individually using the read.csv. So here's red wine and white wine. And then you can see that when we look at them, there are 12 columns. But when we merge this, it'll have no way of telling the red and white wine apart from each other. So to make it differentiable, we did red wine $type and then set that to red. So it'll add a column for red wine that'll then signify that that's red wine. And then we did the same thing for white wine to signify it's white wine. So then for example, we can look at this new data set of red wine and we can see that there's another column here, type, and it's all says red. And then for the white wine, it'll all say white. So then when we go through and use the rbind function, which is binding the rows, so rbind is for row binding, we merged the two into data merged. So then you can see here that there's all type red. And if we scroll down to the very bottom, the white. So essentially they just stacked the rows on top of each other to make one big mass data set. And then to summarize and look at our data a little bit more, we can look at the column names, which you can all see here. So it shows a lot of different things. And the one that we're focused on is the fixed acidity of each. And then to get a better visual representation, I have to run all of it here just to make sure that ggplot is downloaded. We use ggplot to make this graph to kind of visually represent the fixed acidity based by the density of the number of wine types within the range. So you can see here that the white wine peaks lower than red wine, meaning that there's more white wine of lower density than red wine, which kind of indicated to us that maybe red wine overall was more acidic than white wine. And then here's the code that we used here. Here we used ggplot and then a density function. And then we can get into the code.
Yeah, so below is going to be our code for the permutation test. And our p-value limit is going to be 0.05, which would mean that at the end of this, if our p-value is greater than 0.05, then there's not a statistically significant difference between the mean acidity levels in red and white wine. And we thought by looking at the graph above that there could be a significant difference in those acidity levels. And so that's what we wanted to test. So for our null hypothesis, we have that red and white wine have no difference in their mean acidity. And for the alternative hypothesis, we said that red and white wine do have a difference in their mean acidity.
Yeah, so now getting into our actual code. This is kind of the code that goes and randomly assigns the acidity values into two groups. And that's how we will compare. So starting off with the set seed, we put that as 1, 2, 3. This makes our kind of data replicable, or as we repeat it over and over, it'll give us the same population every time. Then we made n is going to be the number of repeats that we go through. That's going to be just a big number, 10 to the 4th. Our vector null dist, this is a vector that we populate with simulated differences in the means, which goes on in the for loop. With the vector temp, we use the tapply function. This just took our acidities for both red and white wine, took the total means of them, and we display those as temp1, temp2. This brings us, as seen there, this brings us into our OG test stat. So the OG test stat is the difference of the average red versus average white. We chose this as it shows that there is a difference between the two acidities. Going down to the pooled DAT vector, this isolates our acidities in the data merged function, so we get both the red and white acidities.
And then one thing too to mention about the null dist is we decided to populate it from the get-go, just because then once we're all done with the code, if negative 999 is still populating null dist, we know something went wrong. So it's a sort of check for us at the end. Yeah, and then so when we get into the for loop, this is what is going to be populating our null dist n number of times. So it'll populate the null distribution with 10,000 different simulated test statistic values, so the simulated differences in means. So to start out, we populated these with a sample using the sample function, so we can look at what that does here. So sample will take a sample of the specified size. So in this case, our size is the sum of all of the red wines. And then from the element of x, so our x in this case is 1 to the length of our entire data set. And then it'll be doing it with or without replacement. So for us, it's going to be without, because we want each value to only be used once. So just for a little example, if we did sample 1 to 5 and then had the size equal 2, you can see that it's picking two numbers, 4 and 5, which are randomly generated from the options 1, 2, 3, 4, 5. So that's what we're doing, just on a larger scale. You can see here that the length is going to be 6,497, and then our size is going to be almost 1,600 here. So then when we populate these, it'll pick 1,599 values from the whole length, and then these will essentially be indices that will later be populated based on pooled DAT. So then when we move down into our fake red, based on these indices that are randomly generated by the sample function, it'll be indices to kind of point towards which data we want to pull from the pooled DAT, which is all of our different acidity levels, and then fill our fake red vector with those values. And then when we want to fill the white, we will do pooled DAT bracket minus these, which will take every number that was not populated into fake red and put it into fake white. So then this will make sure that every value is used once, and every value not in fake red will be in fake white. So then when we've populated both of these, we are going to take the mean of them and then the difference in both mean, and then that simulated difference in mean will be put into the null dist. So every time the for loop is running, another number will be populated into null dist, and every time the I counts up, it's a new simulated difference in mean. So it's a new test statistic.
Yeah, so now that we fully populated the null dist, we can look at a histogram of it as well. And give it a second to load here. Then the line below it as well, what we're going to do on the histogram, as we see here, it's kind of centered around 0. We're going to take the OG test stat, which was the difference in means of the red, all the reds and whites, and we're going to have it be a red line on that histogram. So as you can see in the histogram here, you cannot see a red line. That's because every single acidity that was mixed in null dist was less than the OG test stat. So then if we want to find the red line on the graph, we have to zoom way out, and then there's the red line there. So now going down, we are going to try to find out our p-value for this here. So we're going to make two vectors, tail 1 and tail 2. Tail 1 is going to be the number of values in null dist that are less than or equal to our OG test stat. Tail 2 is now going to be the number of vectors in null dist that are greater than or equal to the OG test stat. So as you can see,
And it's number of values, not vectors, just
number of values, yes.
Yep, number
correct.
of values in null dist.
Thank you. So
Yep.
then as you can see for tail 1, number comes to 10,000 because
Mhm.
every single value is less than our OG test stat. If we run tail 2, that number is going to be 0 as all of them are less than our OG test stat. So
none of them are greater.
or none of them are greater.
Yeah,
Yes,
yeah.
that's it. So then we make a new vector called take this, where we take the minimum of our 2 tails. Now we take the minimum here because it ensures that we actually do get a tail when we double it in the next step, as we don't want more numbers than we actually have test statistics.
Because if we doubled it and we used the bigger one, it would be greater than test statistics, than the number of test statistics.
Yeah. So then once we have that minimum, we're ready to calculate our actual p-value. So we're going to take this value, add 1 to it to include our OG test stat. Then we multiply it by 2. And we do this because it's a 2-sided test. We're not necessarily saying red or white are greater than one or the other. We're just saying that there's a difference in them. We divide that number by our n, this is the number of recycles in our for loop. Then we add 1 to it as well to include our OG test stat. And then we get our final p-value.
So now for a conclusion, we have that since our p-value was 0.0002, we are going to reject the null hypothesis in favor of the alternative. And that just means that we can say that red and white wine have a statistically significant difference in their mean acidities. So just a summary, we took the 2 data sets and combined them for easier usability. We did a permutation test using a for loop to see if there was a statistical significance in the mean acidities of red and white wine. And we concluded, based on the p-value that we got, that there is in fact a statistically significant difference.
And I found I had a typo, so we did the for loop to see if there's a statistical significance in the difference of the means.
Yes, yes, perfect. And just for some context, wine acidity plays a key role in how the wine feels on the tongue. And the greater the acidity, the more crisp, but lower acidity will feel smoother.
So yeah, that's what we got for you guys today in terms of how to do a permutation test using some fun data we found.